Yeah, hi team. So let's get started. So in the last session, we have seen about the table space management and what is a customized table space and what is a default table space. So before we discuss the practically about the table space, today we just discuss about the page layout and introduction of page layout and how it looks like. Okay, so then followed by the demo which was left from the last session where about the table space. Okay. So before we go depth into page layout, we can just recall our storage units. We know that one bit is equal to one binary digit, right? So it is like zeros and ones. Finally, the data will be stored in the storage layer in the form of zeros and ones. Okay, so one bit is one binary digit and 8 bits is we call it as a one byte, right? So 1024 bytes equal to 1 kilobyte and 8 kilobytes equal to our PostgreSQL default page size, right? So this we know. Whenever we initialize the cluster, by default, our Postgres page size is 8 kilobytes. So usually in the page, the actual raw data will be stored, right? So if you take a table space, so table space having a set of files, which we call it as a data files or uh, table file or whatever file name which we call, right? So that file, that physical file is again divided into number of pages, okay, based on your data. So it has number of pages. So each page size is 8 kilobytes. So whenever you create any table, okay, and if you just try to insert a one record, if you just go and check the size of your that file, okay, it will be 8 kilobytes. Okay, that we will show even practically. Okay, so this is our default uh, page size. Inside this page only, our table rows will be fitted, right? So, and if we take the page layout, so basically it has so many components that we'll discuss each component. What is the use of that component? And basically, if you see uh, for table which we are defining the data type. So the data type is very important, right? So if you create any table, we declare the column and the column data type. So based on the data type, in memory, it will allocate the bytes, right, in the KBs. So for example, if you are creating an integer data type, it has 4 bytes. If you are creating with a float, it has 8 bytes. And if you create any column with the text, okay, it is like unlimited, but we can say 32 bytes. So based on your data type, it will allocate the space or storage in the row, okay? So this is just a recap of our storage units. So in going forward, we discuss more about the bytes. Okay, so we should not confuse it. Okay, so 1024 byte will form a 1 KB and 8 KB is our default PostgreSQL default page size. Okay, so as discussed, like page size is 8 kilobytes, and basically this page contains your table data or index data. So it may be anything. And we have different kinds of access methods for tables and indexes. So basically, if you see in this screenshot, for table, the default access method is heap. Okay, so we call it as a heap tables. So whatever the data which is storing in the page, we call it as a heap tables. Okay, and for index, we have different kinds of access methods. The default is B-tree index. Okay, so the access method for index by default, it is a B-tree, but based on your index type, which you are creating, the access method will be defined. Okay, but by default, it will be B-tree index. And for table, it's a heap table. Okay, and if you take a page, 8 kilobytes page, so it has a row data as well as row header, both information it has. Along with this, the page will also have the page header along with some line pointers and free space, special space information and so on. So that we will draw in the paint how this looks like. This page consists of your header as well as your information. Okay, and also it has the row header has some basic system columns information as well. So what are the system columns we have, and when it will update, that we will see in coming going sessions. Okay, don't worry about that. So one of the main important system column we call it as a CTID. So basically in Oracle terminology we call it as a row ID. In Postgres we call it as a CTID. So CTID, if you see in this screenshot, I have selected the CTID comma star. Star is nothing but all the columns data from the table. Okay. So basically these are all hidden columns. Whenever you select the data with the select star from table name, it will only give your original data. For example, in this table, we have only one column and the column data is 1 to 10. But I also call the CTID. CTID is one of the system column. It is hidden. Okay. If you explicitly call the CTID, then only this output will be displayed. Otherwise, if you just give select star from one name, this particular output will be displayed. Since I explicitly called CTID, so I also have this system information. Okay. So basically where this particular system column will be stored, we have a row header. Okay. So inside the row header, we have few system columns. Okay. One is a CTID. So CTID is pointing to, for example, 0. Basically page will start from 0. Okay. So from in the 0 page, what is the first line pointer? So where it is exactly pointing, we call it as an offset. Okay. So for the first row of your data in the page 0, it is pointing to 1. Similarly, in the page 0, it is pointing to second row. Same, similarly third and so on. So this is how the CTID will be pointing to your data based on your page. So this example is for the 0 page because page will start from 0. Okay, so let's draw a diagram so that it's easy for you to understand. So for example, if you take a table space, so this is my table space. Table space name may be anything. Okay, it may be customized or default. So for example, I call it as TBS1. So I've created this table space, and this table space have a set of physical files, right? So we call it as a data files or physical files or file node name, whatever we call, right? So this for now I'm just giving as a physical file, and this physical file, each physical file size is less than or equal to 1 GB. So this is, we know that. So basically whenever you create any table space, okay, that table space have table file or data file, okay, or physical file, right? So each file is 1 GB of size, right? So we know that once this 1 GB is filled, it will generate a new file. So for example, assume we have only one file, maybe which is less than or equal to 1 GB, okay? And this file having number of pages. This file is finally divided into number of pages, right? We know. So this is one page and this is other page. So assume this is page will start from 0. Okay, page 0, page 1. This is my page 2 and so on. This is my page n. So physical files is divided into number of pages, right? So each page, for example, if you take, this is my page 0. So this is my page 0. Okay, so this page again consists of so this is page 0. So this page 0 looks like this. Okay, so inside this page we have this is my page header. Okay, so this page header is of 24 bytes in size. Okay, and we have line pointer or item pointer. So whatever we call. So basically line pointer size is about 4 bytes. So, and we have here free slots. This is for future inserts, okay? And this is main important. So we have row header followed by row data. Row header plus row data. And here we have something called special space. Okay, so this is how it looks like. Each page looks like this. Okay, so in this case, I have table space TBS1. It has number of physical files. Each file will be 1 GB. And if you take each page, it is divided into number of pages. So if I take only one page 0, so this is how it looks like. Similarly, page 1 also looks similarly. Page 2 and so on. Okay, and this page consists of page header, which is 24 bytes, followed by line pointer, and it has the free slots, and it has the row header plus row data. This is my actual data, and we have special space. So basically this page header, this 24 bytes, this is 8 kilobytes, right? This entire page is 8 KB. Okay. In this 8 KB, I have page header of 24 bytes, and I have line pointer of 24 bytes. Okay. And this row data will be depends on what data type you have defined. Okay, so based on that data type, it will allocate the number of bytes of storage. Okay, and we have special space. This is for index. We can say for index access methods. So this area will be used for only index. So it will write some metadata information about only the index information. Okay. And this page header 24 bytes is having so many fields. We can say so that we'll see even okay, this looks like this. Okay, if you see the page header, so the page header having this information. Okay, so LSN, checksum, and so on. This everything we'll discuss. Okay, for now we have a page header of 24 bytes, and we have a line pointer. So what is the main use of this line pointer? So line pointer will points to your actual row data. Okay, so it will point like this. Probably currently my data is pointing to 1. Okay, so it will point out like this. So this line pointer will point to actual your row data. So for example, currently this is page 0. In page 0, it is currently that table having only one record. So it is pointing to that record. Okay. And for example, if you are fitting the data in the second page, it will point to the for example, second page, and currently the data is maybe 50 row or maybe 20 row. So it is pointing to that particular actual row data. So this is the line pointer. Okay. And here we have free slots. So free slots also consist of so here we have this is lower and upper. So basically free slots is this is for future inserts. Okay, it will have the information from which slots we have free space to insert the future data in the page. Okay, so it will point out. So lower and upper. Okay. So from where the free slots available and up to which particular point of line pointer we have free space. Okay. So it will have the lower and upper based on this lower and upper. So it will have the information about the free space for future inserts. Okay. Or maybe for future data. So we have page header of 24 bytes. We have line pointer, which will point to the actual rows. And we have free slots. So free slots is for future inserts. Okay, it has a lower and upper, which will point out from which area to which area we have free space based on these values. Okay, and we have row header plus row data. Okay, so this is the actual row which we are going to insert in the page, and it has a header as well. Okay, so we'll see what information we have in header, what information we have in the page header. If this data we can able to read from few extensions that we'll discuss even practically. Okay, so row data is our actual data and number of columns for this. Okay, let's draw about how the row looks like. If you take this row and it has a row header, this is my row header. This is also like 24 bytes of size, and we have column 1, column 2 and column 3. So for example, I have created a table with a column C1 of type integer. Okay, so it will allocate 4 bytes, right? So because my integer is 4 bytes. And this column 2 I have created with float. Okay, this is of 8 bytes. And this I created as varchar or something. Okay, so or maybe big int. Okay, big int is about again 8. So whatever data types which you define, for example, if it is text, maybe we can consider as 32. Okay, so for example, column 3. So based on the data type which you define, it will allocate the space to your row. Okay, column 1, column 2, and so on. So this data types plays a major role. Okay, for allocating the space inside this row data and row header. Okay, so this is how it looks like. Along with your so along with your original columns, we also have some system columns, which probably 6 system columns we have. Okay, among this one is the city ID, which I'm talking about, city ID, and we have xmin, we have xmax. Okay, so these all system columns we will talk. Okay, you will understand better in the MVCC class how the system columns will be allocated and how the data will be inserted inside the system columns. Okay, so for now, just remember, along with this columns, we also have some hidden system columns, which this is the 3 which I have listed, but we also have the other 3 as well. Okay, so that you will understand better in the MVCC class. So this is how the page layout looks like. So we have a table space, and the table space is divided into number of physical files or table files. Each table file size is 1 GB, and this table file is divided into number of pages. And the page, each page have the page header, line pointer, and it has the free slots, row header and row data, followed by special space. So page header have information like it's a 24 bytes. It has general information about the page, including the free space, the line pointers. It has the checksum, flags. It also have the lower and upper, exactly where the free space those information this page header consists of. Okay, so we'll discuss each and every field about this page header. Okay, with the even practically also. And we have a line pointer which is actually pointing to your row data. Okay, and this free slots we know. This is for future inserts. And we have row header followed by row data. So this is our actual row. This is the row looks like. So each page may have some 5 rows, or based on your data types, it will fit, right? So once this page is full, then it will create the other page. And in this page, it will be stored again the same data. Okay, once this is full, then it will have other, and so on. So it will keep on filling your data, right, in the pages finally. And if you take your row data, this is how it looks like. It has a row header again. And this row header also consists of some information about this record, like, for example, CTID is one of the information that we can able to see from row header. And we also have xmin, xmax. It also have info max. Okay, info max is one of the attribute based on your data. What type of data you are storing. If it is having null values, it will have some sort of entry. If it doesn't have null values, it will have some sort of entry in the row header. Okay, that we will see even practically how the info max looks like. Okay, and it also have the offset. Okay, offset of the data. So this all information also exists in the row header followed by row data. So based on your data types which you define. Okay, and the special space is something. Write some metadata information about the index access methods, I can say. So we have different kinds of access method. So if you, by default, it is a B-tree index. So if you create any index, okay, if you create any index, so basically this index will store finally in the page only, right? So the index data will be stored in the page, and it will point out the special space having some offset or maybe a line pointer. Okay, it will point out to where the page index has. Okay, it will just point out to that page where the index data has. Okay, that kind of sort of metadata information will be stored in the special space. This is mainly for index access methods. Okay, it doesn't have any data. It has some sort of metadata information about the index. Okay, it will point out to the page where the index data has. Only that kind of data it has. Okay, this is how the overall the page layout looks like. Okay, when coming to slides, so basically this is the command which I'm trying to. Okay, this we know that each page is 8 kilobytes, and we have different access methods. So based on the access methods, for example, if it an index, it is as a B-tree. If it is a table, it is a heap, right? And it also have the CTID. This is one of the, I can say this is one of the row header information which I'm trying to look. Okay. So just remember page size is 8 kilobytes, and this is how the page header looks like. I have selected the page header. This is the page 0. This is IMDb is my table. So I have selected for page 0 of this table, what is the row, what is the page header information? Okay, so based on this query, so let's start from page header, get raw page, and this is my table, and this is my page 0. Okay, so here what I'm trying to do is, I have created a table space TBS1, and I have created a table called IMDb. Okay, this is my table name. Okay, so this table name is finally created with the physical file, right? So table file of 1 GB, and I'm trying to select here for this table 0 page. What is a header? Page header in I'm trying to look. Okay, this is the query. So if you want to select this kind of data, if you want to inspect the page, and if you want to see more information about the page, by default, we cannot see. Okay, we have to create some extensions called PG free space map. Okay, so that extensions we have to create at the PostgreSQL database level, and that set of extensions will come as part of your contrib modules. So whenever we install the Postgres cluster, So we have discussed one term called contrib models, right? So it has some set of extensions. So in that extension, we have one extension called PG free space map. If you install that extension, we can able to see the page header information and inside the page what we have. Without that extension, this particular function will be not created. Page header function will be not created. Okay? So once you create that extension, we can select page header information of this table of 0 page. Okay. So if I find this query, this is how it looks like. Okay, it has LSN information, it has checksum, it has PG flags, lower and upper, special, version, prune XID. So these are all the flags, or maybe we can say some kind of metadata information it has in the page header of 24 bytes. So we are talking about this. Okay. If I run the select statement, I will get what data I have in the page 0. Okay, it has LSN, checksum, flags, and so on. What is the LSN basically? Okay, so LSN is like we can say in Oracle we have SCN, right? So basically in Postgres that SCN will be represented in two forms. One is the transaction ID and the other is LSN. Okay, so this LSN, it will generate a hexadecimal value. Automatically Postgres will keep on generate this value. Okay, and this information will be stored in the page header. Currently, what is the LSN? What is the sequence number in Oracle terminology? Okay, that information has in the page header, and it also have the checksum. So checksum is something which we have to enable while building the cluster. If not, then it requires a downtime to enable. So basically, checksum is to detect your block corruption, okay, or page corruptions, we can say. Okay, by default it is disabled and the value will be 0. If you enable, the checksum value will be 1 here. Okay, this information we can also see from control file, okay, or from the page header. So if it is 0, then your checksum is disabled. If it is 1, then your checksum is enabled. Okay, so currently it is disabled. I have 0 here. And PG flag. Okay, so this flags, basically we have some system flags like 0, 1, 2, okay, predefined flags. So what is the use of these flags? Probably we will understand better in the MVCC class. So based on your transaction IDs and transaction ID freezes, okay, this flag may change, but by default it is 0. Okay, so for now, just remember we have a special flags. One is 0 among that. We also have some flags 1, 2, 0, 1, 2 also. So that depends on your number of transactions, and if it reaches the transactions, your flag value will be changed. Okay, so by default it is 0. We will understand better in the MVCC class what types of flags it has. And we have PG lower and upper. This is lower and upper values which I'm talking about. So it has, we can say, start of free space and end of free space. Okay, in the free slots. Okay, so this is the two values will store. So currently the lower is 452. From 452 to 488, we have free slots, okay, to fit the data. This is what it has. Okay, PG lower and PG upper. And we have special, okay, PG special. This is also like kind of offset, which will point out to your index. Okay, so based on the index which you have defined, it will point out. So we call it as this sort of space, we call it as a special space. And version, okay, version is default 4 after 8.3. So they left as 4 value, which is constant value after 8.3. And we have prune XID. So basically this is also very important. This is something we can call it as a partition pruning. Okay, if you have some set of partitions in a table, what is a partition pruning? Whenever you try to select some set of range of data, it will directly go and search in the particular partition, right? Similarly, this prune XID is something called in the table. Okay, when you create any index or any type of index on any specific column. So basically this prune XID will have some sort of entry, like it has to directly go and fetch the data from that particular page. Okay, similarly kind of partition pruning. So this all information consists in the page header. Okay, Any questions? So we will also see practically this all things, okay, how to fetch the pages, header information based on some extensions.
So, Sukesh, one more question. So, what is the advantage of having checksum enabled on the page?
Yeah, checksum is if your page is something corrupted, okay, it will detect the corruptions.
Okay.
So it is just to detect your corruptions. If you're not enabled, so it will just skip, okay, it will not able to detect until unless we find so from application side they are not able to connect, and if you find that it is something corrupted, so then only we understand. Otherwise, if you enable checksum, we can scan all the pages if any block corruptions has if any block corruptions is having some corrupted data, okay, so we can see with the help of checksum.
Okay, so is that is that mandatory to be enabled, especially on prod systems, or is that we skip it? Or
yeah, it's good to enable, but the thing is here one catch is if you want to scan all the pages, if anything is corrupted, okay, so we have to stop the cluster. So when cluster is up and running, we cannot scan it actually. So we have to stop the cluster.
Okay.
Enable or to disable or to scan or to detect the checksums. I mean, we have few options like enable, disable, and check. If you want to check all the pages is healthy or not, it has to be stop your cluster. So this is one more drawback in Postgres. In online, we cannot able to detect it. Okay, we have to stop the cluster and we have to check. So it's good to have this checksum. Okay, basically this checksum we not check every day, right? So probably whenever we have any block corruptions, sometimes we can able to detect what page is corrupted and that page has what information. Based on that, we can take an action. So based on the backups, we could able to restore, or maybe if it is an index, we can rebuild. So based on that, we can take an action. Yeah. Okay. So especially for PCI production systems, it's good to have checksum.
Okay, got it. Thank you.
Yeah. So this is how the page header looks like. And now we can just have a 2 minutes how the row header looks like. Okay. So this is the row header I'm talking about. So row header is also 24 bytes. It has this particular information: line pointer offset, line pointer flags, length, xmin, xmax, ctid, info max. So this all information we have in the row header. Okay. So what is basically this LP? So LP is nothing but the line pointer. Currently, it is pointing to 1. Okay. So which we call as it is indicating currently 1. It starts with the 1, right? Line pointer will starts with 1. Okay. Currently, it is pointing to 1. And offset. Okay. So offset is nothing but this is just a position of your item pointer. This is currently at the position 8120. Okay. This is the offset of your line pointer. So which means the line pointer, for example, it is 1, right? So from there, which location? Currently, it is pointing from 1 to 8120. Okay. The difference between offset and line pointer is the actual it is pointing to your data, right? So this is currently in the 8120 position. Okay. And it starts from 1. This is what this meaning is. Okay. And we have something called LP length. Okay, this is your actual row data. Okay, your row data is currently 72 bytes. Okay, and also we have something called xmin and xmax, which is a system columns. So xmin, yeah. So basically this xmin and xmax are the system columns. Whenever you insert any data, xmin will be allocated. Whenever you do update and delete, xmax will be allocated. So this system columns we will discuss more in the MVCC. For now, just remember xmin will be updated whenever you do insert. Xmax will be updated whenever you do any update and deletes. Okay, and this is a CTID. CTID is looks like this. Okay, on the page 0, currently for the line pointer 1, what information we have, that kind of sort of information we have here, and info max. Okay, so Infomax is something called 16 bits of information we can store. And so basically this information have, for example, you have something called null values. Okay, how it looks like if you have if doesn't have any null values. Okay, based on the bits it will represent. If the last bit is 0, that is which means you don't have null values. If the last bit is 1, you have null values. So some sort of information it has in the Infomax. Okay, so even we'll see practically how it looks like. And finally, if you see this offset, okay, this offset is nothing but it's a row header offset, which means like every header of the row is occupied of 24 bytes, right? So that is what it is telling. 24 bytes of your row header is occupied, and this is the data. So the finally your data of 72 length, okay, it is storing like this, okay, in some encrypted format. Okay, this in the page. This is how the row header looks like. Okay, so probably what we can do is we can tomorrow we can just go and check practically to understand better how it looks like. So for now, we just remember this diagram, how the page layout looks like. So each and everything we'll discuss. Okay, this is just a summary of each and everything. So even we'll see practically and internally how this looks like and what is the importance of your data types. Okay. Yeah. So Raj, you can share and start the table space.
Yes, Suresh, yeah. Let me share my screen. Are you able to see my screen?
Yes.
Okay. So just we can go through table spaces. Okay, so just like install the PostgreSQL 15 cluster, and just I installed into the normal location. I did not pick any my customized data location to store my data directory. Okay, so we will start with the the table space management in PostgreSQL. So the theoretical thing already started, and also we discussed about default table spaces, right? Okay, so just let me connect to the PSQL prompt. Okay, so here what we can do, we can just find the databases names. Okay, this is a command /db. Okay, and also we have another like a catalog view, that is pg_table space. Okay, so anything will work like based on your requirement. You can pick the db or pg_table space, and also if you want to see more information, you can press the db plus. Okay, so DB Plus will provide these many options like name of the table space and owner of the table space. If it is a customized table space, okay, then location will be there. Okay, and also it will provide some other options as well. Okay, and what is the size of the table space? Those information also will be available here. Okay, so then what we can do first, okay, and we will search, even we will find what are the list of databases. Okay, you can see here, these are my default databases. Okay, what I will do, okay, I'll create one database. Okay, so and before that, what we can do, I'll create some customized table space, or maybe this way. Okay, we can start with leave about the customer table space. We can discuss about first a default table space. Okay, this we already discussed in our last class. Okay, so I will do create database first. Database Skyhoops. Okay, so I want to find what is the OID of this particular database. Okay, so we have the view, catalog view, that is PG_database. Okay, here we can select OID, that name is database name, and what else? We have like that table space from PG underscore database, where that name equal to Skypes. Okay, so we can see, and this way we can select instead of filter condition. Okay, so you can see this is my OID of a database, Skyoops. Okay, and where I'm storing. Okay, so all this particular database related data. Okay, it is going to store into the like default table space. Okay, the default table space OID is 1663. Okay, so we can see OID of the table spaces by using PG underscore table space. Okay, select OID SPC name from PG underscore table space. Okay, so you can see, right? The OID of the database Skyoops is 24576. Okay, and the OID of the like table space, the default table space is 1663. Okay, you can see here. Okay, we are not picking any table space while creating the database. Okay, by default. Okay, as we discussed in our last class. Okay, so by default, it will pick and it will use the PG underscore default table space to store your user data. Okay, PG underscore global is our useful to store the data dictionary information. Okay, and PG underscore default data table space will be useful to store your like user data. Okay, so we can like as we discussed. Okay, so how the directory layout will be. So we have like $PG underscore data directory. Okay, and this is a master directory. Okay, under the master directory we have the base directory. Okay, under the base directory we have the OID of DB. Okay, under the OID of the DB we have the like OID of table or index. Okay, table or index file. Okay, so this way, like on PostgreSQL, if you are not using any customized table space, okay, so the directory layout or the directory layout of your particular table structure will be stored in your PostgreSQL OS location, something like that, if you're not using any customized table spaces. Okay, so we can go into OS location. Okay, we can go into OS location where we are now. Okay, so we can go to PG data. In PG data, we can see base directory. Okay, in the base directory, you can see 24576. Okay, so 24576 is my OID of Skyoops database, right? Okay, so then suppose, so where I'm into PostgreSQL. Let me connect to Skyoops database. Let me create one table. Create table T1 ID some integer. Okay, so if I want to find the OID of this particular table, okay, so there is a catalog view that is like PG underscore class. Okay, PG underscore class. So here we can select OID, okay, and a relation name, and what else? Okay, and relation table space as also we can find it. Relation namespace. And I think maybe this we can leave it. Okay, leave it, let it be. Okay, and then what we can see, namespace not required. File node, real file node, and real relation like table space. Okay, and these columns are enough. Okay, from PG underscore class where relation name equal to, what is the table name? Relation is nothing but table here, table name here. Okay, so this is my, actually this is my OID of the the table or relation. Okay, and this is my OID of, okay, this is my OID of real file node of our table. Okay, so as we discussed in our last session, okay, so whenever if we create any table, okay, so the table OID will be created, and also the real file node name or table file or data file OID also will be created in our physical location. Okay, so initially the OID of the table and the OID of the real file node or table file node will be the unique. Okay, so whenever if you are performing any operations, like whenever if you're performing any truncate operation, or whenever if you're performing any reindex operation, or whenever if you're performing any clustering operations, okay, so the OID name will be changed. Okay, the OID name will be changed. Okay, so we will see how it will be. Okay, so now, so as we discussed, okay, this particular OID will be created under where? PG data, under the base, under the OID of DB, under here you will get the real file node or table file OID. Okay, so we will see here. Okay, up to here, like we can see, right? Okay, this where we are now, we are here. Okay, up to here PG data. Okay, and this is the base subdirectory under the PG data. Okay, here we can go into 245. Okay, okay, this is the base directory, base subdirectory. Under the base directory, so we are using the PG underscore default. We are not using any customized table spaces. So the OID of the database will be created under the base subdirectory. Okay, this is my OID of the Skyhoops. Okay, under the Skyhoops, okay, I created the table T1. Okay, the table T1 OID is 24577. Okay, it means the table file OID. It will be created under the particular database. So now if I see here 245 star, okay, you can see here, this is my OID of my table. Okay, or maybe we can call it as table file OID. Okay, or real file node of my table. Okay, or my data file OID. Okay, so what we can do, we can insert some data. So I think someone is asked, right, why initially it is 0. Okay, so initially it will create the 0 whenever if we start inserting the data. Okay, whenever if we start inserting the data, then it will start allocating the page size. Okay, it will start allocating the page. Okay, the page size will be starting with 8 KB. Okay, we will insert some data here. Insert into table T1 values. Suppose maybe if I insert 1. Okay, syntax issue. Spelling mistake. Okay, so if you see here, if you press the same command, okay, so initially the OID of the table will be created. Okay, then after whenever if you start inserting the data into your table, okay, then the table file OID will get the space. Okay, so how it will get the space 8 KB of the pages. Okay, so it will keep on allocating the space to this particular OID. Okay, until the space available in your storage location. Okay, df-h. Okay, this particular page will grow. Okay, this particular page will grow until 31 GB. Okay, and again, there is a limitation in PostgreSQL. You know, whenever any table is created. Okay, so the table file will be created. A table file will be grow up to 1 GB. Okay, that is the by default size. Okay, the same 1 GB file can grow or can change. Okay, so whenever you have a requirement like I don't want to store my table file with 1 GB. Okay, so you can pick your own size of your table file, but it is available, or it is like it is going to give while you are initializing your Postgres SQL cluster. Okay, while initializing your Postgres SQL cluster only, you need to define how much of the table file size you need to pick. Okay, by default, if you're not picking anything, by default it will pick the 1 GB of the table file. Okay, if you want to have like my table file size is like maybe 5 GB or 10 GB. Okay, while initializing the cluster, you can pick that information. Okay, and you can change this particular value. But after initializing the cluster, so there is no option in PostgreSQL to change your page size. Okay, so once the page size is like filled, once this page size is filled, like 24577 page size is full. Okay, so the PostgreSQL internally will provide the like names of the pages like something like this. Okay, automatically. So maybe like we are unable to like load, but it will take some time. Like we can load it with some functions. Okay, 1 GB of data. Okay, so if you like the page size is like full. Okay, so a 1 GB file is full, then PostgreSQL automatically will allocate the new page with the 1 GB. Okay, something like this. Okay, it is automatically will allocate. Okay, so the file of the like table is okay. The OID of your table. Okay, the OID of your table. Okay, and followed by extension 1. Okay, even this will grow until 1 GB. Even this file also will grow. This file also will fill. Then and again another file will be allocated, that is like with extension 2. Okay, with the OID of like a real file node. Okay, and so on, it will be allocated. Okay, based on growing your particular table. Okay, up to here clear, guys?
Yes, yes.
Okay, so then what we can do, we can create any customized table space. Okay, we can create some customized table space. Before that, what we can do, where we are now, we are here. Okay, we can go here. Okay, so make dir. I am going to create some sky tbs location. Okay. Okay. So in this location, I'm going to create my customer's table space. Okay. So suppose create table space. Suppose my table space name is TBS1. Okay. And location. And I'm picking this location. Okay. And one more important thing you need to consider here is, okay, while creating, okay, so while creating the table space, okay, so there are some reserved names in PostgreSQL. Okay, you should not mention the table space name starting with PG underscore. Okay, those are the keywords. It is internally reserved for the PostgreSQL, like internal table spaces or internal user related things. Okay, so any objects, okay, any objects are like any table space or users. Okay, you should not create with PG underscore extensions. Okay, so that is one just note from the like PostgreSQL. Okay, you can create any table space in your own name. Okay, but it should not be like PG underscore like starting name of your table space or usernames or like some other objects. Okay, so those are reserved for the PostgreSQL internal objects. Okay, here you can see we created the table space under the location is particular location. Okay, and here you can see there is a warning. Okay, there is a warning. The table space location should not be inside of the data directory. This is a simple warning for like a DBA. Okay, it means as a DBA, the best practice is we should not create like the table space into your like data location. Okay, of your PostgreSQL cluster. Why? Because the data location or data directory location of the PostgreSQL, it is containing the huge amount of files. Okay, huge amount of internal files or system files. Okay, so this particular data location, it is containing, see, you can see all the dictionary information related things, all data related information, all file, wall file related information, all like parameter file information, everything will be stored under this particular data location, okay, data directory location. So that's why it is giving the like error message or warning message, we can say. Okay, so best practice is you can choose some customized location, okay, and you can create the table spaces inside that. Okay, that is the best practice. Okay, so and also it is not harmful if you are like proper DB and you are able to manage it. Okay, that is not at all a problem to store under the data directory. But again, so the data means that you are storing the data into data directory. It means it is like highly accessible. Okay, it means you are like you are picking the data. It means you are retrieving the data or inserting the data. You are writing the data something into particular tables. Okay, it means this location will be like having the input and output operation. Okay, instead of that, you can allocate this particular data directory into some other mount point. Okay, and you can pick the data directory location. Okay, the table space location into some other directory. That is the best option. Okay, so we created now one customized table space. Okay, now we can play with this customized table space. Okay, so before that, we can find what is the OID of my particular table space. Okay, what is my OID of the particular table space? Okay, so we have the view, or we have a like direct like command. Okay, DB. Okay, so DB, it will provide. Okay, Okay, so what is the name of your particular table space and what is the owner of that? Okay, what is the owner of that? Okay, by default, we connected with the PostgreSQL, okay, as a user. Okay, so then by default, it picked the owner. Okay, so otherwise, if you want like change the ownership of your a table space. Okay, here you can, while creating the table space, you can mention here owner name. Okay, if you want to have owner of this particular table space is different owner, and here is the location. In this particular location, we created the table space. It means whenever if you are creating any table by using this particular table space, okay, so then all your objects, okay, if you are using any table by using this particular table space, okay, so then the table objects will be created under this particular location. Okay, we will see now. Before that, we can see what is the like OID of this particular a table space. Okay, so we have the view like PG underscore table space. Here select OID, SPC name. Okay, so that is enough. And also there is one more function, internal function, that is PG underscore table space underscore location. Okay, this is the internal function. We can mention OID from PG underscore table space. Okay, where SPC name equal to what is our table space? TBS1. Okay, you can see this is a catalog view. PG underscore table space is a catalog view. With the help of this catalog view, we can pick or we can find what is the OID of our table space. Okay, and this is my OID of the table space. Okay, this is my OID of the table space. This is table space name, and this is my location. Okay, with the help of this internal function PG underscore table space underscore location. Okay, with the help of the PG underscore table space view only, we can get the location also. Okay, and other way is if you want to find this location, okay, then we can use the DB and DB plus view. Okay, so based on that particular command also, you will get the information about the table space. Okay, so as we discussed in our last class, okay, so whenever if we create a customized table space, how the customized table space will be created in OS. Okay, so the OS location will be PG data. Okay, and followed by, so there is a directory. Okay, there is a directory. The directory name is, okay, PG underscore TBL SPC. Okay, under this particular location, okay, we have the OID of table space. Okay, so OID of the table space, and there is a symbolic link will be created. Okay, and the symbolic link, okay, under the symbolic link, so what we can see there is a unique name. The unique name is PG underscore major version of PG underscore major version of your PostgreSQL cluster, then catalog version, okay. So under that, okay, so in the pg underscore table space location, pg underscore table space subdirectory location, you will see only this information. Okay, you will see only this information in the sense, information in the sense, you don't see this particular location, you don't see this particular location, but you will see you will see void of the table space. Okay, void of the table space, and there is a symbolic link. Okay, there is a symbolic link. You can say there is a symbolic link will be created. Okay, symbolic link will be created. Okay, and the symbolic link is pointing to actual location. Okay, it is pointing to symbolic link pointing to location, customized location. Okay, so under the pg underscore table space subdirectory, you will see the OID of the table space. Okay, under this particular location, you will see OID of the table space, and this OID having the symbolic link, and this link is pointing to customized location. Means customized locations means we created this TBS1 table space into this particular location. Okay, so you will see this thing now. Okay, where we are now? We are here. Okay, we can go to data directory location. Okay, here data directory location, you can see pg underscore table space. Okay, this is my like default subdirectory it will create while initializing our cluster. Okay, so here if you see, okay, so this is my OID of table space. Okay, where is my OID? Okay, here this is my OID of the table space. Okay, and there is a symbolic link. It is pointing to my actual location. Okay, guys, until here clear? This is, as we discussed, the same we are saying here. Any doubts?
No.
Okay, so then what we can do, we can go to this particular location, customize the location, and we can see here, there is a unique directory will be created. Okay, the unique directory name is pg. Okay, and then there is a major version of the PostgreSQL, and there is a catalog version. Okay, so this catalog version, from where it is coming? It is coming from the control file. Okay, it is coming from the control file. Okay, so to get this particular information, there is a function in PostgreSQL. Okay, the function name is, okay, first thing is we can see select version. Okay, this is my PostgreSQL major version. Okay, and this is my minor version. Okay, so then the catalog version, we can have one function pg underscore control underscore location, control underscore system, I think. Sorry, select pg underscore control underscore system. Okay, so with the help of this internal function, we can pick the catalog version of your PostgreSQL. Okay, this version information is available, and it is like getting from the control file. Okay, and this version information. Okay, so this version information will be unique like for your entire PostgreSQL cluster. And also, whenever if you are performing upgrade operation, okay, whenever if you're performing your upgrade operation, okay, that time this version information will be updated to have your latest catalog version for your PostgreSQL major or minor version. Okay, so okay, anyhow, this one we can discuss much more in like PG upgrade related classes. Okay, but this particular this particular number, okay, it is the catalog version number, and this catalog version we are getting from the pg underscore control file, okay. So to get that information, we have the function called pg underscore control system, okay. You will get this information, okay. So with help of this particular function, okay, this is the catalog number, okay. The same number we have here, and and this particular number is unique for your PostgreSQL cluster, okay. And the same number will be the catalog number and catalog version will be changed whenever if you perform any upgrade activity in PostgreSQL, that we will see in our PostgreSQL upgrade classes, okay. Guys, until here clear? Just we are going inside of this particular directory, and we can see here anything is there, okay. Here we have not created anything, okay. So what we can do, we can create one table, okay. So create table T2, or what we can do, we can use some functions. We can create some there are some okay. Here if you mention just table space tbs1, okay. Okay, table is created, and we can load some data with help of the these functions, okay. These functions we can get it from Google only. We created just to have load some sample data, okay. Okay, so then what we can do, we can insert some OneLake records inside that, okay. And before that, what we can see, okay, so we can see here, okay. You can see here, we have the table, okay, employee, okay. So table, okay. So we can find what is the location, okay, what is the location of this particular employee table, okay. So we have another function, to get the OID or a complete OS location, okay. First we can see from pg underscore relation, okay. Where is this one? This is the table space, and here we can see from class, okay. So we can see employees. This is my table, okay. You can see the OID, okay. The OID of our employee table is 582, okay. Initially, as we discussed, the OID of table file of employee is 24582, and it is using the table space, okay. It is not using the default table space. It is using the customized table space, okay. So as per our discussion, this OID, okay, this OID will be created under, okay, under where, which location? The customized location, okay, the customized location. But in the customized location, okay, so how it will be created, okay, it will be created like, okay, so it will be created something like this, pg data, okay. So then we have sorry, not pg data, okay. So pg underscore 15 underscore catalog version, okay, catalog version. And under that, okay, so we have OID of the DB, okay. Under that we have the OID of table space, okay. So then after we can see OID of 24582, okay. This is OID of our employee table. Guys, you are following what I'm trying to say here?
Yeah, Raj.
Okay, so we can see now, okay. So, and before that, what is the OID of my database? PG underscore database, we can get it right. Okay, so yes. You can see SkyUp's OID is 24576. Okay, so previously we don't have any information here. If you plus ls-ltr, here you can see 24576. OID of my database is created. Okay, so if we go inside this, okay, so where we are now, okay, this is my we can say the data directory location. Okay, under the data directory location, so we have created the like some customizer location. Okay, under the customizer location. Okay, under the customizer location, so we have the like the catalog related information, the catalog related what we can say, the number is created. Under that we have the like a database OID. Okay, after the database OID, the table OID will be created. The table OID is like 2457582. Okay, so ls-ltr 245. Okay, and if you see here, the OID of, okay, the OID of my table is created. Okay, and it is initially with the 0 size. Okay, and 0 size. If you start loading the data, you will see like we discussed about the FSM and VM, right? Okay, so those are the some extinctions, and those are the two important things in PostgreSQL. Okay, so FSM is like it is going to have what is the free space available in our pages. Okay, the free what are the free space available in our pages, and the VM is like what are the dead tuples information in our pages. Okay, all those things will be like available, or it is like storing in this particular PG underscore FSM and also a PG underscore VM. Okay, so here if you see, okay, if you see automatically whenever if you start loading the data into that, okay, whenever if you start loading the data into that, okay, so here there is no other like other than OID of your particular table. Okay, the table file, there is no other like actions are created. Or whenever if you start loading, okay, whenever if you start loading the data inside that, okay, so these three things will be created. Anyhow, this is by default the table file OID. Okay, after that, if you start loading the data and if you're performing the DML operation, okay, the based on that DML operations, automatically PostgreSQL will create underscore FSM and underscore VM. Okay, so these two files will be created by default. Okay, by PostgreSQL internally. Okay, FSM is containing the how much of the free space is available in our PostgreSQL pages. Okay, related to the particular table file, and the VM is having the like how many dead tuples. Okay, how many dead tuples are, which are the pages having the dead tuples. Okay, those information will be available in the VM. Okay, and related to VM, we can discuss much more in vacuuming classes. Okay, so in the vacuuming classes is related to dead tuples only. That time we will discuss more on this particular part. Okay, so then what we can do, okay, so what we can do, we can perform some truncate operation, and also there is a one more view. Select PG underscore relation underscore file path, and here you need to mention employee. Okay, so this is the another view. It will provide. Okay, so the entire path of your table file. Okay, entire path of your table file. You can see this is my table space subdirectory under where where data directory, okay, under this particular subdirectory, we have the OID of the table space, okay, and this OID of the table space, what it will do, it is having the symbolic link, it is pointing to like our actual location of our customized table space, okay, and if you go to the customized table space location, then we have this particular directory, unique directory name will be created based on your major version and catalog version, okay, and then there is a OID of the database, okay, there is a OID of the database, then there is a OID of your table file, okay, so then what I discussed, whenever if you perform truncate operation and reindex operations or clustering operations, okay, this OID will be changed, okay. Initially, whenever if you create your table, okay, that time the OID of the table file and OID of the table will be same, okay, and throughout the cluster, okay, so whenever the table is available in PostgreSQL cluster, the OID of the table will be unique, okay, and the OID of the table file or data file or real file node, that will be changed based on your operations, okay. So now what I will do, truncate from employees, truncate not from truncate table employees. This is syntax. Okay. If you truncate the table, if you see here, what is the file path? If you see here, my table OID, okay, or maybe not OID, not table OID, table file OID or data file OID, okay, or real file node OID, okay. So it will be changed automatically, okay, it will be changed automatically. If you go here, you can press the same operation, okay. If you see here, the OID will be there, okay, in the physical location, OID will be there, but the entire information will shift to the new OID, okay, new OID of the table, okay. Whenever if you start loading the data, or whenever if you start loading your data into your particular table, okay, we can say the OID of the table file of our table employee, this is a new one, okay. Whenever if you start loading the data, okay, then FSM and VM, okay. So FSM and VM, see, I did not drop anything here, okay. Internally, PostgreSQL will manage these particular FSM and VM related topics or related things, okay, internally, and it will just hold the OID of the old table file, but this is useless. This is no need of this particular OID, but if you start loading the data, into your PostgreSQL table, okay, after truncate operation, so new OID will be created for your table file, okay, and also the FSM and VM, okay, whenever if you start loading the data, FSM and VM will be automatically created for this particular new OID, okay, and these OIDs will be managed by PostgreSQL engine internally. Okay, guys, clear what I'm trying to say and what I'm trying to convey here?
Yeah.
Okay, so this is the concept of the PostgreSQL OIDs, okay, and we are going to give one homework for you. I think Darpan already did, okay. I created my employee table under where. So this is my database, Kayups, okay, and where I created my employee table under the TBS one, okay. So there is a requirement in my PostgreSQL a database, okay. So there is a space issue, okay. The particular table space TBS one that is located in particular location, right? This location where we are now, okay. In this particular location, there is a space issue, okay. So my senior DB is asking me to move this particular table space from this location to another location, okay. So how we need to perform that particular operation, okay. That is a homework for you, okay. And please confirm in the WhatsApp before tomorrow. or maybe take your time. Okay, take your time. We are not sharing the like content for today class related to document. Okay, we will provide this video recording. Okay, we will share the same like document tomorrow just to practice from your side. Okay, I want to change. First thing is I want to create my TBS one having the employee table. Okay, so I need to create another table TBS2. Okay, I need to move my employee table inside this particular TBS2 table space. Okay, how we need to do? Okay, and what are the steps you need to follow? Okay, those things. Okay, just do the research from your side and please come for tomorrow class after completion of this. Okay, any doubts guys before closing the class? It's been I think
So you want us to move the table space from one table space to another table space? Is that what you're saying, Sriraj?
we are not moving the table space. We are moving the table from one table space to another table space.
Okay. The table from, okay, got it. Okay.
Okay. So currently employee table is under the TBS1. Okay. Here a typo. Okay. TBS1. Okay. I want to move this employee table from TBS1 to TBS2. Okay. Yeah. So that is the homework for you guys. Okay. So it's been almost 7:55. Okay. No problem. Okay. So yeah. Any doubts before closing the today class?
Yeah, the page layout diagram. Can you share that PNG file?
Yes, we can share that one. Okay. No, not a problem.
Thank you.
Yeah. Okay, that even that particular diagram will be continued for like tomorrow classes as well. Okay, so we are discussing the concept based on that particular diagram only. Okay, these are like some interesting topics in PostgreSQL. Okay, so you will get to know. Okay, and we will share the like complete diagram for you. That one. Okay, don't worry.
Thank
Any
you.
other doubts? Malati, Darpan, Dan, Banu, who else? Gopi, Shiva. Any doubts?
Hey, Shriraj, one question. When you truncate the table, you said this OID will be changed to a different number. The old one will still exist. So will that get removed during vacuuming operation or?
You will see that particular topic. Okay, so you will see how it will behave. Okay, so it is just maybe we can keep it as a curious. Okay, we can keep it like that only. Okay, but you got it right. You can see the table OID will be there. Okay, but whenever if we start loading some data, what we can do, we can load some data here. Where is my here? Okay, this is my inst of. We can load inst. We can load 10,000 records. Okay, so my insertion is completed. If you see here, okay, if you see here, array, I reveal the thing. Okay, so it is. You can see here. Now we have only FSM. Okay, we don't have VM. Okay. But when the VM will be created, okay, and how it will be decided, okay, it will be decided internally by PostgreSQL, okay, but whenever if we start doing the DML operations, some modification in your PostgreSQL, okay, if you do some delete or if you do some like update operations, okay, just by default, okay, the VM will be created during that particular operation. Why? Because in PostgreSQL, suppose I don't want to take you in that particular direction, but I will give a hint, okay, related to VM, it is pointing and it is useful for the vacuuming operation, okay, it is holding the information about the dead tuples. Dead tuples means here in PostgreSQL, there is no table space management. Sorry, there is no undo table space management in PostgreSQL. Whenever if you are performing the delete operation and whenever if you are performing the update operation, okay, the old values, okay, the pre-image data will be stored into your same table space, or maybe we can call it as the same table or same table file or same data file or same real file node. Okay, so So that particular old value, we can call it as a dead tuple. Okay. So whenever the dead tuples is like it's keep on coming into PostgreSQL table, okay, then VM will be created, okay, automatically be the PostgreSQL. But the related to dead tuples, okay, what is the how we can manage the dead tuples, okay, and what is the visibility, okay, how many versions are dead tuples we can have, okay. So these all the concept, okay, we will discuss in our later sessions of vacuuming operation. Okay, there you will get the better understanding. Okay.
Sure, got it. Thank
Okay,
you.
so yeah, we can close the session, guys. Sorry for that. We took half an hour. I think hope it is okay for you guys. Okay, why? Because we need to complete this the particular topic. We don't want to extend into next sessions. Okay, that is the reason we took it. Okay, so yeah, if there is no doubts, we can close the session for today.
Thank you.
Okay, thank you.
Thank you,
Thank
Sriraj.
Thank you.
Thank you all. Thank you all. Bye bye.